Okay, so let's get into the pyramid and the capstone. So if you noticed, I don't have tons and tons of squares and circles laid on top of each other. I want to keep it clean and simple so you guys can understand what I'm doing. Those other ones were done so that I could show you the actual numbers and their relationship to each other. So in Giza, they are showing a relationship. The Great Pyramid shows a relationship to the other pyramids, and they show relationships to the Great Pyramid, and they do it through number and geometry, just like I showed you. And so when we're talking about what we're talking about, which is precession, universal geometry, however you want to talk about it, everything kind of is related to each other in one way or another. And when you start seeing the way that the geometry fits into itself, or the way it unfolds or folds, you can see you get a glimpse of the way it kind of works, right? So this whole thing with 10 degrees, I didn't just come up with it out of nowhere, right? I studied some alchemical drawings. I mean, I stand on the shoulders of some great guys. One of them is Athanasius Kircher, another one is Robert Flood, and another one is Robert Boyle, which I'm going to show you where I've gotten some of this stuff from. Then of course it just goes from there when you are familiar with these with the symbols and with what they're showing you in these alchemical drawings. So right here is an example of what I was showing you in those numbers. So this is our 10 degrees right here. So these two angles that you see, one here is, so if I move that 5 degrees to the left and this 5 degrees to the right, then I get a total of 10 degrees, right? And as you can see, as the radius gets larger, so does this. So this is a 594 right here, circle. And if you notice, it is at 5184 is the size of the circle. We multiply that times 36, and we get 186,624. And we multiply this, which is the 756 circle, times 66 times 36, we get the 2376 for the circumference. So this number right here represents 10 degrees, and this number times 36 represents the circumference of that circle. And it also represents more than that, which we'll see. So just to kind of show you where I've gotten some of this information from, if we come over and take a look at, this is a Robert Flood drawing, and I've added the 10 degree marker in here to kind of show you. So you can see that what he's showing here, this being the this center circle, which we call Terra, and if you remember, I was showing you the Earth in the center of that huge radius. So it's not that everything is circling the Earth, it's that everything looks like it is from our perspective, right? So so from our perspective, this is the way the universe looks. We see everything around us. It looks like everything's moving, but everything is kind of moving, right? So when they show this and they kind of show these angles, this angular geometry in here, you can see that what he's showing here is 10 degrees, right? And what he's also showing here is that there is this, because this represents the sun here, and this up here represents something else. I'm not really sure exactly what that is yet, what it represents, but I have a guess, but I'm not going to talk about it yet. So anyways, if we were to take this and notice where these things cross, as they cross in the middle of this circle down here, and you notice he's got a couple of circles here, or actually I do, which I'll show you here in just a minute on what that means. So let's take a look at somebody else real quick. Here's Kircher and what he did. And I actually did an image similar to it a while ago. If you zoom in on it, you can actually see he's got 72 here. But if you take 36 and you multiply it times 2, all you do is you got 72, which are half the size. So instead of 5184, you would have 2592. You'd have 72 of those. 72, and then 2592 or 25920, these are precession numbers. Okay, So, and then when you do overlays on this kind of stuff, and this little circle he's showing right here, he's showing it for a reason, okay? Because it matches up to what I'm going to show you here in just a little bit. This is what they do in these alchemical drawings: is they put stuff in there you have to know what to look for. This is the kind of stuff I don't want to show you right now. All these are calculated out. They have certain numbers associated with them, you know, like 518.4, stuff like that, 5184. Here's a guy that I didn't think I would ever understand what he was doing, but he created a book called Curious Mathematical Forms, and he was done in the 1600s, and the only place you can find pictures right now of this is on a military site. And I never really understood what in the hell he was doing until now. And now I find myself doing the exact same geometry that he's doing. So these are not just drawn on here. He's calculating these things out with certain numbers. I can guarantee you that. And this right here, you're looking, you see all these little concentric circles? These concentric circles are here as well. So if we put this 10-degree marker on top of here like this, he's measuring the 10-degree thing. All right. So, and over here, I'm guessing it's probably, I don't know what it is. I mean, I haven't measured it yet. It could be 5 degrees though. So, I didn't just come up with it, so it's actually something that these guys have been showing us for quite some time. And so now that it gets to our measurement time, right? So there's 2 places that I've measured this so far. I measured it using a satellite image, and it's the best one I can find out there, and I think it's a pretty good one. If anybody finds any better ones out there from this particular view, it has to be a top-down view. And that brings up another point. When you are looking at this stuff, then the perspective of view that we need to be viewing it from is from above, because that's the way that they're presenting everything. If you want to take a look at the missing capstone, the only way you can really see the ratio of it compared to the size of the pyramid is from directly above, because you can see that there's a missing square right in the middle of that large square, and that gives you an immediate visualization of the ratio between those 2 squares. That's the way all this stuff works in the Giza complex. The geometry I've been showing you so far with the various concentric circles and stuff like this, and I've done it all over the Giza complex, in fact, that's exactly what they were doing. They did it with the pyramids, they did it with the whole complex. They were trying to prove a point about something very large, possibly as large as the universe itself, I don't know, but they were trying to show, here's how you figure it out. So, 2 places I've measured it. I'm going to show you how I got to what I got to. So, if you take a look at this right here, this 10-degree thing, 5184 is the number that you see right here. Now, if we come over to this this particular website right here, and this guy's got some good stuff, the 31104, which I was showing you, but right here, he mentions that, for example, if the Kali Yuga really has an effective length of 5184 common years, okay, so he's mentioning that, and then here he says the length of the Kali Yuga will be 1/10 of that total, 5184 common years. Okay, so we come back over here to this. So the missing capstone represents a segment of time when we're talking about precession, and more than likely it represents a Kali Yuga, which is 72 of the great years. So we have 72, which is also the same life as basically man. So man lives to be about 72 years old. So then we have 72 of those, because 72 times 72, or 72 squared, is 5184. And so if we click here on this right here, let's just take this guy and put him right in the middle. So now he's right in the middle, and if I click on this guy right here and I zoom in, you'll notice that those dotted lines pass just on both sides of the 5184, right in the middle of the pyramid. And then this square is the 5184 divided by the square root of 2. Okay? So if we turn on our image of the satellite, let's turn that on real quick. So first of all, you have to get all your measurements right, and then what I usually start with is I start with the 756 size square. You'll know if your measurements are right because everything will be thrown off if you're not. So I would say the margin of error here is probably a foot, maybe. But a foot is close enough so that you could figure out what they were using. Okay. So if we zoom in on this, and let's just move this guy out of the way so you can see what I'm doing. So if you take the 5184 and you divide by the square root of 2, and let's move this guy out of the way too so we can actually see that area. Now if anybody can find anything that's clearer than this out there, let me know. But we can pretty much see what's going on here because we've at least got one half of it, right? We've got the other half too, but it's just not as clear. But if you look at it for a little bit, you'll see. But we've got this side and we've got this side, which are very clear. All right. But I'm always looking for a better one. So if anybody knows of one that's out there, let me know. Okay. So since I have the pyramid size, the outer size, then I know that that this size is going to be more than likely correct as well. Okay. So what I did was I created this type of thing, and just so I could show you and visualize, you can visualize what it looks like, but let me just zoom in just a little bit. So these are all 36,656, which are 5184 times the square root, or divided by the square root of 2, but I can pretty much go around this whole thing. That's really, you can really see it right there. Alright, and then so just to show you that it's actually the square root of 2, we take the 5184 and we can place it right on top of there. So the diagonal of that square is 51.84 feet, which is actually the size, or excuse me, it is the angle or the slope of the pyramid. So it's the degrees of the slope of the pyramid. It represents a Kali Yuga, more than likely. And it also is 1/36th of a number which is found that has basically all of the factors that we are interested in, and it's also a segment of the circle that squares the 756 pyramid. So there's a lot of things going on here that say that this is exactly what it is, plus of course the measurement. Now let's take a look at the one on Google Earth. I don't trust Google Earth as much, and here's what it looks like. If we put the circle on top of it and look at the square underneath, you can see that the square root of 2 gaps right here. So even if it's off a foot or something like that, you can tell, I mean, that it's 5184. They wouldn't use anything else. They wouldn't use 50. They would use 5184. And we've already seen them calculate the numbers out, right? So if we go over to Google real quick, and let's just take a look at the top of the pyramid. And there's the top of the pyramid, and so if you notice what they've done here is they've kind of rounded these things off. So what you have to do is you have to draw an imaginary line from this edge all the way down to where it meets. So if you do that on both edges, they meet right in the middle here. Okay, so that's where we need to start. So if we're going to measure a path we need to start right here because that's where they both intersect. One right there, and the same one on the other side. And we get 5111, which is basically 51.84. So there's two different areas, one with a satellite, which we know is more than likely correct, and Google just seems to be confirming it. And I've already shown you what they've done with the middle pyramid. So 5184 is the length of the diagonal of this thing, and 36.656 would be the square root of 2 of that. Now, if we treat it as 36 instead of 36.656, then some interesting things come out, because if we treat it as a 36 by itself, then 36 times 4, the perimeter of it would be 144, right? And then, of course, 36 times 36 is 1296. And we know what 1296 0 is, right? These are all precession numbers that we're talking about here. So, and this is just scratching the surface of what all this stuff means. Okay, so when we haven't even gotten into the whole complex yet and started to analyze that yet. But I'm pretty damn sure that what we're looking at right here is the size of the capstone, and that size is 5184. So that's my analysis on that. The reasons why that they did what they did, why pi is not as helpful as you might have thought it was going to be when you're dealing with numbers that you need to find out of a list of factors. I mean, if you're dealing with stuff that are irrational numbers that run on forever and are different every time, they look like noise when you're trying to find things. And that's why pi doesn't work in these situations as well. So anyways, you guys have a good weekend, and if I have anything else, I'll put it out there for you. You guys take care. I'll talk to you soon.